So we'll do a very simple example on magnetic flux. We have a plane, a certain area, and we have a magnetic field that's making some angle with the normal to the plane. So if this is a small element of area on the plane, the area vector is perpendicular to the area, to the surface, and the magnetic field vector is making an angle theta. And it's a uniform magnetic field, so that means the angle is the same everywhere on the plane. So it's a very simple problem. We want to get the total magnetic flux through this plane. So the flux, magnetic flux, is integration of B dot dA, which means it's integration of B dA cosine theta. Now in this particular problem, the magnetic field is uniform, so the angle is constant between B and area vector. So cosine theta is a constant. It's the same value everywhere, same angle. And also B is the same value everywhere because it's a uniform magnetic field. So I can take B and cosine theta outside of the integration. Get then integration of dA. What's integration of dA? It's just the total area. So you get B theta times A, which is BA cosine theta, and that's the total magnetic flux through the surface. You can see, for instance, in the case where B is perpendicular to the area, to the plane, then cosine 90 is 0 and you get no flux. So this, remember, think about it in the intuitive sense. There are no, in this case, field lines going through the surface. They're going parallel to the surface, so you don't get any flux. And in this case, when the magnetic field is exactly in the same direction as the area vector, then the angle is 0, cosine 0 is 1, and you get the maximum flux. And so the number of lines going through this surface has a certain value, B times A, proportional to B times A. So the units of magnetic flux are Weber. If B is in Tesla and area is in meter squared, then Weber is Tesla meter squared.